Welcome to Hello Tomorrow. Hello Tomorrow is a podcast where we introduce remarkable individuals and their work to the world. A new episode will be available every fortnight on Apple Podcasts, Spotify, and all other major platforms. Now, over to Subhash.
Hello Tomorrow is all about introducing remarkable individuals and share their knowledge with the world. If you would like to support the podcast, you can donate on Buy Me a Coffee at buymeacoffee.com/hello tomorrow or on Patreon at patreon.com/hello tomorrow. We thank you for your support in advance. Hello, I am Subhash and welcome. This is our first interview in the Knowledge series. As a part of the Knowledge series, we speak with experts and try to understand complex topics in a simpler form for easy consumption and also understand their journey in the path of learning. Let me introduce Srikanth Kallakuri, who is the Director of Engineering at Standard Cognition. Srikanth is a friend, roboticist, researcher, and an entrepreneur. His experience spans from autonomous navigation, driverless cars, machine learning, and multimodal cognition. He strongly believes that technology can solve the world's problems. Welcome to my podcast, Srikanth, and let's get started.
Thanks, Subhash, and it's very nice to be here and great chatting with you.
Can you please run us through your education, where you've studied and what all you have learned?
Yeah, I've been in the area of robotics for a big chunk of my life now. I did my bachelor's in India, during which time, obviously, we did a lot of adventures together. And that was what now seems like more than a few decades ago, but it was a few years ago. And after my bachelor's, I did my master's at Carnegie Mellon University in the US. And during my master's, I was mainly focusing on robotics and autonomous navigation and mapping for robots and machine learning and all those areas. Right after my master's, I started working. And after working for a few years, I came back for my PhD at the same Carnegie Mellon University. And during PhD, my main focus has been on multimodal speech recognition, basically using all the other modalities like visual information, context, etc. But 3 years into my PhD, I had to drop the course, and then basically that was the end of my university education. But I have been taking a lot of courses online and updating myself ever since.
That's a great education background you've got. Can you talk us or run us through your work post your MS at Carnegie Mellon?
Yeah, my first job was again after my master's at CMU, and that was in a research center in Japan. It's called it's called ATR, which is Advanced Telecommunications Research Institute International. That's a long name.
Yeah.
So it's a research center located in Kyoto area.
Okay.
In Japan, where the focus has been on robotics and autonomous navigation and brain-machine interfaces. So I worked there for a couple of years where I did a lot of indoor navigation for wheelchairs for elderly persons and also for people who cannot move. And I was also involved in some brain-machine interface projects where users can actually drive their wheelchairs in house-like environments just by thinking about some things.
Wow.
And I was also involved in large-scale mapping projects, where we were mapping huge supermarkets. And when I say mapping, it's more like mapping for autonomous navigation, which is much more denser than the 2D maps that we see in Google Maps or something like that.
Right.
And also when I'm saying about indoor maps, it's basically a 3D model of the environment, and where you understand everything, where different things are located, where the driveways are, where there are shops, and all that information is embedded into these maps. And after working there for a couple of years in that research center, I came back for PhD in the US, which I mentioned I dropped it halfway through. And after that, I took a small break, and I worked in Dubai at Emirates Airlines for almost a couple of years. I was working in the innovation lab there, where the main focus has been on improving the user experience or the flyer experience or the traveler experience in Emirates flights, especially on applying some data science and machine learning in order to like keep it, like learn from your previous travels and like suggest you better deals, or like give you a better experience for you to be prepared for the next travel, or like what to do, and if you're going for a vacation. So more personalized information being presented to you. And in addition to that, I was also involved in some analysis on like pricing and other things for the flight tickets, like applying machine learning for understanding the trends of pricing, and bringing in the context of like the calendar, like the date on the calendar and other things, and how do those affect the pricing.
Must have been a pretty fun project working on so much of data.
Definitely, it is. It is really fun in a sense. Like working for an airlines company is obviously a great experience in my life, and obviously Emirates Airlines has like a huge fleet of flights and a lot of A380s, and it's very nice. And also our office was located right opposite to the airport, and it was a wonderful phase of my life where I was working on like the state of the art data analysis, and also like in such a nice hospitable a company like Emirates, which is known for its hospitality and airlines. After my work at Emirates, I came back to US to start a startup. That's when like I founded one of the startups, like along with two of my friends. It's called Explorer.ai. So this startup mainly focuses on building large-scale maps for driverless cars.
Mhm.
As I mentioned, these maps are much more denser than Google Maps that we see like online.
Are these maps generated using LiDAR?
Yes. So these maps are generated using lidars, cameras, and a lot more information like the satellite imagery and everything. So this is not like one modality that creates these maps. Like you combine all this information, but most of the 3D information was gathered from lidar. You're absolutely right.
Sure.
And also, as I mentioned, like we overlay the camera information onto these LiDAR maps. We overlay the information that is obtained from satellite imagery onto these LiDAR maps, and basically come up with a very dense representation of the world. And this dense representation of the world is used by driverless cars to navigate around. Just to give a brief overview of the driverless technology, I would like to split it into like three aspects. One is mapping, the second is localization, and the third is motion planning and decision making. Obviously, I come from more of a mapping side of this technology, so obviously I'm biased towards more granular distinction of mapping and localization than motion planning and decision making. But to briefly explain these three things, mapping basically deals with recording all the static information in the world, where there are strays, where there are lane markings, where there is what are the rules at a particular point on the road. Like, can you take a right turn? Can you take a left turn? Or is that a stop? Or what is the speed limit? All this static information about the world is embedded into this blob called map. And that is mostly static, but it is dynamic in the sense that things keep changing in the world. There'll be construction happening on a particular road, or there will be some lane closure in a road, or like there might be some accident, or some other thing that is causing the traffic to be diverted to a different road. Or all this information is embedded into maps. Then comes the localization aspect, which is basically you look at this static information and you look at the real-time data that is coming from lidars and cameras that are on board the vehicle, and you try to match these two and see where exactly am I. For example, if you have a map with some particular store on your left side, and your camera sees that on your left side, then basically you know that you're exactly at that particular spot. But this is much more explaining, because you need to be as accurate as possible on the road. Because if you're going at 80 miles per hour on a freeway, and if you're off by like 2 degrees or 3 degrees, like obviously you're going to be way off in a few seconds, right?
Yeah.
So that's localization. And next comes obviously the most important aspect of motion planning and decision making. So this is basically all the real-time decisions that the car makes in order to avoid hitting someone, or like avoid like making any wrong decisions on the road, or like avoid any collisions, or making sure how the traffic light is, like is it red, green, or orange. And based on that, like making all the real-time decisions and motion planning comes into the last chunk. What we were focusing on at Explorer.ai was mainly the first aspect of creating these denser maps and making those available to these cars. And also the most important part, which is to keep them up to date, to reduce the time between the change that is happening in the real world and the change that is being reflected in these maps that are being provided to the cars. So the more upfront information you have, the more safer your driverless car can behave rather than trying to do everything in the real time. So that was the premise for our startup. And we worked on that and we built pilot projects for like multiple autonomous car companies. And we also did some projects with some of the very well-known big companies in the autonomous driving space. And while doing that, we also observed that a lot of consolidation was happening for autonomous vehicles. If you see now, basically you can count with your fingers in maybe one hand the number of autonomous vehicle companies that are there, and also the number of startups that are working in areas related to autonomous vehicles. But 3 years back or 4 years back, that was not the case. There are like 100 companies, 100 startups like working on different aspects of these autonomous vehicles, but now they got consolidated. So observing these market trends and all, and also the very fact that a different company approached us with a proposal of acquisition, and that is Standard Cognition. So Standard Cognition is a company where I currently am working with. And here we are developing technology for autonomous checkout, where you can walk into a convenience store or a supermarket, grab the items that you want, and just leave. And all the checkout, all the barcode scanning and all will be taken care automatically by the technology which we are developing. So these people approached us and proposed us that we use our knowledge and expertise in mapping for indoor environments to basically create a spatial cognition or a spatial understanding inside a store. And that was very attractive for us because obviously here the go-to market is like right there, like right in front of our eyes, because going to we can actually work on real stores data, and also we can deliver the product in a very quick way. So we got also all our team was very excited about this aspect, and then we switched gears and got acquired by this company. And since then, we have been working on bringing in spatial intelligence to indoor environments. This is exactly what we were doing before, but we were focusing on outdoor environments for driverless cars. But what we are now doing is applying the spatial intelligence for indoor environments, specifically for autonomous checkout use case in supermarkets, convenience stores. So brings to the current time where I'm still at Standard Cognition, working on developing the autonomous checkout technology by using cameras that will be on the ceiling. And here, what we do is basically not build stores ground up like some of our competitors who are working on autonomous technology, but our biggest advantage lies in the fact that we are very good at retrofitting to the existing stores. So you bring us a convenience store like a 7-Eleven or Family Mart or something, and we can actually make it autonomous checkout ready within a few days or a couple of weeks by putting cameras on the ceiling and not touching anything on the shelves.
That is a great differentiator for the market for sure. So that was quite a good experience that you have acquired over this time. And for a lot of people like me who always like problem solving and keep looking for challenges, I guess something like what you're doing is really exciting, listening to what you're doing right now and the use case that you're trying to fix. So because this is the knowledge series, why don't you share a little more with us about in a one-on-one level about AI, ML, and robotics? Are they all different? What are they, and how does one have to see them?
AI basically is trying to give human-like intelligence to the machines. right? So it has like multiple aspects to it or multiple dimensions to it. One obviously is machine learning, where we teach the machines to see the patterns in the world,
Yeah.
like how our brain perceives the world from our eyes or ears and makes sense out of it, trying to teach the machines to do that. In addition to machine learning and understanding patterns in the world, in order to achieve AI, we also require other aspects like we need better computational capability.
Mhm.
So, however complex your machine learning algorithms are, however advanced your machine learning algorithms are, unless you have the right computational capabilities, there's only you can only go till certain level.
Yeah.
So, having better computational complexities is definitely one of the important aspects of AI. And in addition to that, having better bandwidth, for example, how you transmit information between you and the machines or between machine and machine also plays a key role in advancing AI. Because currently, the way we transmit our information between us and a machine is limited by the speed of typing or the speed of speech, right? So unless we achieve better speeds there, it'll become hard to teach the machines and make the machines learn about the real world as good as we do,
Yeah.
and obviously respond to it. So like this, there are some of the segments of AI, but again, you can consider a lot more to it. And to give an example, like there are different levels of this AI systems. If you take a proximity sensor that turns on the light as soon as you enter the room and turns it off like as soon as you leave the room, that's also technically an AI system because it's perceiving the world through its sensors. It is actually computing what to do with that sensory information, and then it is showing an effect in the world by showing you some actuation, turning on the light or turning off the light. So, and from that is like very crude level of AI where the kind of intelligence it has is very simple and straightforward in a very narrow sense. But to achieve artificial general intelligence, like how we combine the context, the location, the weather, the visual information, the auditory information, the noise in the background, and like all the experience you had with people like someone or like visuals like this. Like so, our brain actually combines all this information to make sense out of what's going on around it, and then how should I act at a given point of time. To achieve that level of AI, there's a long way to go, and we need to add a lot more complexity to what we currently have.
So what you're pointing out is that most of the segments, if not individually, together are giving us a lot of our solutions.
Yes, absolutely. So it's not all or nothing, right? So even having like just a speech recognition kind of AI, which just looks at audio signals and converts it into words, and then using NLP or natural language processing, you can convert these words into understandable sentences. That is using only ears. So it's basically like a human which doesn't have, it's basically like a human which, or who doesn't have any skin or eyes or tongue or anything. All the other senses are dampened and only has ears. That's still usable because not all AI agents need to have all the modalities or all the capabilities. But the most general intelligence can be achieved only when you're looking at the surroundings as a whole and not just like singular modality. Just looking at video and then trying to make sense out of something will never be complete unless you have the other modalities added to it, other sensory information added to it.
Sure. So can you share a few use cases that are mostly being used, or use cases that most of our audience can recognize?
Yeah, definitely. A lot of obvious things that we see online every day, like how it is becoming more and more personalized on Facebook, Instagram, or all the social media platforms,
Yeah.
or the kind of recommendations you get on YouTube or Netflix based on the videos that you have watched. All this has a lot of dependence on machine learning and AI on the back. For example, compare the kind of Google results you used to get in 2004, 2005, and compare the kind of Google results for the same keywords you get today.
Yeah.
And this is definitely made possible because of a lot of advances that happened in the last decade or more. In addition to what you see online, there are a lot of areas where we are currently applying machine learning as we speak, in trying to make our lives better. For example, obviously autonomous vehicles, where accidents is like one of the biggest causes of deaths
Right.
around the world, and having machines which can compute at like much faster rates and which can actually act with much more resilience and stability than humans to drive our vehicles will definitely help us. And most of the autonomous vehicle system depends a lot on machine learning and understanding the world. And if you take what we are building, autonomous checkout, millions of man hours or billions of man hours or person hours are being wasted around the world standing in the checkout lines whenever you go to a convenience store.
Yeah.
And just imagine what if we can just automate things and bring in the personalized aspect of going to a convenience store to get what you want rather than making it like a transaction or a business. How nice that'll make our lives to be on a day-to-day basis. So all of these are being made possible with um, the recent advances in ML and AI.
Srikanth, can you tell us the difference between ML and data sciences?
Yeah, I can give my perspective on that. Definitely, I feel there is a huge distinction between ML and the kind of meaning that we give to data sciences in a modern lingo. ML is all about predicting what happens next. ML is all about understanding the patterns in input data. It could be sensory information, it could be visual information, it could be words, it could be audio, anything. Understanding the patterns in it and then trying to predict what that could be. Like basically, you have some data and the labels corresponding to it. And then you have some new sample which doesn't have a label corresponding to it, and you try to predict where it falls. Like you show it some apples and some bananas, and the machine understands some patterns, like anything that looks like red and round are apples, or anything that looks in almost like a color yellow and like which are longer than apples are bananas.
Yeah.
And now you give a random fruit to it or a random image, and it tries to predict what that image is. What is the probability of that image being an apple or a banana? Compared to data sciences, in data science or big data analysis that we usually call, there it's about analyzing the data that you already have. It's not necessarily about predicting what that means or what is the result of it or what is the effect of it, but it's more like making a sense of the data that you already have. For example, if you have the data about the populations or if you have the data about employment history, then you can understand like, oh, okay, these are the different demographics doing these kind of employments or these kind of jobs. Like what kind of so how is the gender balance between a different job descriptions, or how is the what kind of demographics are working mostly in what kind of jobs, or who is earning how much. Like, so this is all the information that is already there, but big data analysis helps us analyze it and visualize it and make sense out of it in a nicer way compared to having it like a cluttered 1 terabyte of data in some hard disk. So that's the difference between the kind of the meaning how we use data science in general usage and machine learning.
Globally, while all of these advances are helping the consumers and users in a great way, I guess there is also this large fear in the governments as well as individuals about their privacy. Any comments on that?
Definitely. I think we need to be very cautious when we are building AI systems. For example, in my company, we from the beginning we have architected our system in a way that we don't get any biometrics from people, or we don't do any face recognition or anything that will be unique for a particular person. It would have been much easier had we architected our system by doing face recognition, because it's very easy to identify people with faces. But we were pretty clear that we want this entire experience to be as private as possible and as safe as possible for individuals to use this. So we architected in a way we are using the most generic things like pose of people, and basically the only identification we have is from the check-in. When you're checking in, like your account information, which is encoded, is the only thing that identifies you rather than any biometrics. So, but like not all applications are as private and as secure as what we are building. I completely agree to that fact. So it's something of concern, and that's one of the primary requirements for any engineer building these AI systems, to respect the privacy of individuals that are using this. And also, there needs to be a lot of government regulation, which is already happening. For example, in many states in the US, doing face recognition by any business is actually illegal. So you can't actually perform face recognition on large scale data. In many states, I think as far as I know, even California, you can't do face recognition. So these kind of, and also obviously Europe is way ahead of anyone else in terms of like securing the privacy of people, with the fear of these AI systems like intruding into individuals' lives. But at the same time, it's also a responsibility for all the engineers and the policymakers to make sure this doesn't happen. But like any technology, this has its own pros and cons, right?
Yeah, taking more of a moral responsibility of not of making sure that their data is not misused. So Srikanth, when can we expect highly intelligent systems in our daily lives? As in, we listen to a lot of systems getting intelligent, right from Amazon getting intelligent to Google getting intelligent. There is so much of intelligence that is getting involved into many things that we use in our daily lives, right from governments using big data analytics and performing analysis on large amounts of data to give better governance, to give the to get closer to the citizens of the country, to using any of our Amazons and Googles of the world. And then in the US and a few other countries, we have autonomous cars as already. So when do you think we can expect highly intelligent systems in our daily lives, and which way do you think we can get them?
Yeah, that's a very good question. And as you rightly mentioned, there are already a lot of highly intelligent systems in our daily lives. Like the very moment we touch our mobile phone, a lot of services we are using are dependent on machine intelligence. And in addition to it, definitely a lot of forecasts, a lot of predictions on public services or policy making are now more and more moving towards using machine intelligence and data analysis in order to make these decisions possible. But one thing I would like to point out is that we always had this, whenever we think of AI or robotics, like we had this impression of a huge metal box, or like a robot which looks like humans with a head, hands, and legs, um, uh, helping us in doing our daily chores, right? So that, I believe, is not going to happen anytime soon in the next 2 or 3 years. That there is at least a decade before we see personal robots entering into our lives that can help us. But as we have discussed, there is a scope for a lot of personal assistance in the form of things like Apple Siri, or visual assistants like Google Photos, and all this information in individual modalities will be brought to us using in a much more effective way using AI. But this expectation of a human-like android talking like humans, thinking like humans, acting like humans is far away. But at the same time, we will start seeing AI embedding into our daily lives at each and everything, from the time we wake up till the time we sleep, or even during our sleep, to be coming into our lives like very soon. The more and more services are available online that depend on AI, the faster it will be. But to see the real actuating robots or like the AI systems that has more than online presence will be slow in coming to our daily lives.
Understood. So, what do you think one should keep in mind while building an AI system?
Yeah, this is something we touched on briefly, like in your question of privacy. Like one of the things that one should definitely keep in mind is the privacy of individuals or the privacy of the users when building an AI system, and it should be more helpful rather than more detrimental to our lives. In addition to it, there are a lot of things that we need to be cognizant of when building AI systems. The first and foremost, I think, is one needs to have an understanding on where to use an AI system or like where to use an intelligent machine. Not all applications require ML or AI. It'll be foolish to just keep applying these things for each and every use case without understanding the downstream effect. So, for example, there was recently an analysis on how a particular district court was using AI to decide what kind of sentence should be given to a particular convict or particular person that was that was arrested, and that's not right in my opinion. In my opinion, that's something that needs like careful consideration by people who are very well versed with the justice system and also the rule of law before actually making a decision. And that's not something you should leave to a machine. And also, another aspect that we need to keep in mind is when we are building an AI system, we should be very cognizant of the diversity that exists in the world around us, especially in countries like India and US. There is nothing that you can say that holds good for the entire country. There are people of different background, different ethnicities, and different cultures, different languages, different colors of skin, and everything. So when you're building an AI system, you should respect this. Otherwise, there is a very good chance like you're biasing your entire system towards one section of people, or you're alienating some sections of the people, which is going to be disastrous going forward. And also, to summarize what I said, like I would say any machine learning model or any AI system is only as good as its developer or as good as its engineer. I would also go to an extent to say any AI system is as diverse as the engineer that builds it. So, or any AI system is as secure as as the individual that builds it. So it heavily depends on the individuals that are building it, and it's a huge responsibility because small mistakes at this point of time in building AI systems are going to have like very disastrous downstream effects as we go forward, where we alienate certain sections or certain genders of people or like certain cultures or backgrounds.
So, because we've touched base about autonomous vehicles quite a few times over this interview, just out of my curiosity, do you think autonomous driving is possible in a country like India?
If the question is it possible?
Yeah.
Then damn yes. But the question is about like, is it possible in the very near future? I think it's a hard challenge. But again, for autonomous vehicles, there are certain defined levels, right? Like level 2 autonomy, level 3 autonomy, 4 and 5. And level 5 is like the highest level of autonomy where the car can drive in known or unknown environments by itself without causing any damage to the surroundings. Or even if it is left in the middle of a desert, it can find its way home. So that's the highest level of autonomy. But if you're talking about level 2 autonomy of autopilot or close to autopilot or like adaptive cruising technologies or something like that, or level 3, which is almost similar to the current autopilot technology in Tesla and other vehicles. So those kind of things will be possible even in India very, very soon. So overall, it's not a challenge that can't be solved. but it's just like more complex or more exaggerated in India because of the lack of specific uh, uh, traffic rules. For example, the lane markings are not available for most of the smaller roads in India, at least the areas where I grew up and where I have studied. And these are all the things that make autonomous driving much more challenging compared to a road with lane markings clearly defined. It's slightly easier for a car to navigate around that. So, in conclusion, like what I would say is like it's definitely possible, and also it's not very far from how fast we can actually make this work in like more organized in the countries with more organized traffic discipline. But definitely it's very challenging, and it's capital intensive as well. Like another thing we need to think about is like, are we ready to spend so much time, so much money and so much resources on making this possible, and what kind of effect will it have?
So we've delved very deep on the whole gamut of artificial intelligence. On a personal level, are there a few rules that you follow in your life? Are there certain things that you've done in your life that have made you successful?
That's a deep question, but one thing I try to believe in is to be conscious of the decisions I'm making. I'd be a very happy person if I can answer why I'm doing what I'm doing at any given point of time. So the why is quite important rather than what you're doing or how you're doing everything. So I always try to understand the fundamental reasons that are compelling me to make certain decisions or do certain things in life. So that's something I want. I want myself to keep focusing on always, rather than getting caught up in this flow of just doing things for the sake of doing.
That's quite intense. Is there any specific advice you would like to give to anyone listening to our interview right now who's interested in AI specifically?
I can share my brief understanding or experience that I've gained working with AI for many years now. It is inevitable that AI is going to make its way to most, if not all, spheres of our lives sooner or later, right? So we should start learning to coexist with the technology, but at the same time, keep the core principles of humanity alive, or keep the core principles that make us different from machines alive. And also for people who are enthusiastic in AI, definitely I would suggest them to think of more innovative ways of application of AI in our daily lives. And also being like there is a very good chance for India to make a difference here by becoming the next machine learning or AI hub in the world, which can develop like a lot of applications that will make our lives better.
And listeners, you can expect most of the episodes in our knowledge series to be a little longer than usual, because we are asking our guests to put all of their knowledge that they have gained over all of these years into half an hour or 40 minutes, which would be really tough. So you can expect our episodes to be a little longer, like this one already. So, Srikanth, is there anything else you would like to add?
It was a wonderful conversation I had with you, Subhash, and it's really nice to discuss with you. And also, I really loved some of the questions you posed on going forward with AI and what we can do with it to make our lives better.
Thank you, Srikanth. Thank you for all of your time.
It's a great pleasure, Subhash. Thank you for having me.
Have a great week ahead and wait for my next podcast with another remarkable guest.
Please do subscribe and share our podcast and do join us on this journey of learning.